Welcome back to the course on advanced green manufacturing systems, and we are studying value engineering in this module. In value engineering, we have seen what is value, what is value engineering, types of values, fast diagramming, identifying the functions, and numerical comparison of the functions. Those things we have done. Now, value engineering methodology as we have seen. I am going to show you a case study in this lecture on value engineering application. So, the case study here is presented and the product that is chosen is foot operated air pump. As I have said, the value engineering concept could be applied to both manufacturing and services. So, more applications in manufacturing are generally found, and also we are talking about manufacturing systems in this course. So, because in manufacturing the quantification is quite easier. Okay, however, quantification can happen in services as well, because sometimes in services the data is in a subjective form, but in manufacturing it has found more application. Value engineering has more applications in manufacturing, in construction as well. Construction, manufacturing, okay, services, and so on. So, this is the product that is selected. It has various components. I will show you what are the components in the information phase and the cost for each component. So, the objective of the study was to improve the value of a foot operated air pump by cost reduction using the 7 phases of value engineering. Actually, this is a work that I did with one of my MTech students, and the 7 phases as suggested by Mudge were used. The 7th phase is general phase. Actually, we started from the information phase. Before information phase, Mudge suggested a general phase. Okay, general phase is just an overview, just an introduction to value engineering, or just gather the resources like people, documents. Just data collection can be one of the part. Value engineering team is more dependent upon data collection and analysis and data implementation. So, using good human relations is one thing he suggested. He said inspire teamwork, because one of the fundamental principles of value engineering is to imply teamwork and to work with a team from different sections of the manufacturing concern. So, apply good business judgment is one of the rules. Judgment has been based upon the facts or data that is quite often used in decision making. So, this is just the general phase. Okay. Next is selection of the product. Selection of the product. A product that is to be used in value engineering, there are certain suggestions given by the researchers who have been working in value engineering in manufacturing. They said it should have at least 3 different sub assemblies to have a proper value engineering application. However, this is not something that is mandatory, but for a big projects or for the projects like foot operated pump, it has certain sub assemblies. There is a piston arrangement, there is paddle, and we have base. Different sub assemblies are there. At least it should have at least 3 or more sub assemblies. It should have 8 to 16 components or actions. Okay, it should be in current usage or planned usage. Anything that is outdated, working on that wouldn't help. So, that is currently being used, or it is to be used in future. Those things all will to be worked. No major changes in the item should be under study or in process, because we are applying value engineering. We are starting from the very scratch. We are trying to identify the functions. We might come up with some solutions in which these functions or the overall design of the product can be changed. So, is there any change that is still under study? That has to be first seen. This comes in general phase. Before we are gathering information, we need to know that whether the product is actually workable or not. So, it must be something on which changes can be made after the submission of the recommendation. So, the top management or the decision makers should be the part of value engineering team. At least one member should be there who should be able to persuade the investors to invest value engineering, because sometimes in value engineering this is actually the study on cost reduction while implementing. Sometime in the initial phases, in the beginning, the cost reduction is not very high. Sometimes there are certain changes for which certain setup is to made, and therefore that setup, the cost or the expenses which are for that are a little higher, and sometimes in very first few months the payback is not good. But yes, if the product is produced for a longer period, obviously the pay would be higher, payback would be higher. So its purpose or functions should be definable, the product's purpose or functions should be definable and understandable. These are general suggestions given by S.S. Iyer, okay, who also wrote a book on value engineering. I suggest you to read this book. So he has mentioned these suggestions in his book. So information phase. In the information phase, as I said, the data and information related to the project is collected. All the guidelines of general phase are very much helpful in this phase. The very first thing is securing the facts. The facts, first step is to secure all the relevant data and information regarding the company, number of employees. Now this company had 50 employees in which this study was carried out. So determining the cost and specifications. The rules of this technique is to determine the cost of various components of the product, so that value engineering team can identify the poor value or high cost areas in function phase. As I said, value is equal to utility per unit cost. So if cost is poor, cost is high. If cost is high, the value would be poor. If utility is less, the cost would be higher. We are just not taking into account the utility viewpoint, because this is the cost reduction study. So high cost functions are to be seen and to be actually identified. Then we need to work on that to provide them in a lower cost if possible. In information phase, as I said, we develop the bill of materials. So this is bill of materials. Okay, bill of materials is list of the materials with, this is actually, this starts from the bottom, number 1, 2, 3, 4, 5, 6 and so on. So this list of material is developed, and we have the very first component as base plate, second component is bucket ring, third component is company sticker, cylinder, and in the second column we have the quantity. There is only one base plate, okay, there is only one bucket ring, okay, there is only one bucket ring, there is only one bucket washer. Similarly, we have two hexagonal nuts, which is component number 12, two hexagonal nuts here, okay, and two hexagonal bolts here. Similarly, we have all these components, there are 24 components, and this is the drawing. This is actually the exploded view, as I showed you the view of the mobile phone. This is the exploded view. Each component, if you say, let me say the component number 6, component number 6 is cylinder cap. So this component is cylinder cap. This component is component number 6, which is cylinder cap. Okay. So all these materials or the components are there. Also we can group the components. For instance, do the components come in one group, and this is the piston group, piston cylinder group. This group is actually, I would say, assembly, because I am talking about components, not functions. This is piston cylinder assembly. Okay. Then all this at the top we have pedal assembly. This is the base plate assembly. We have meter and all those things. Base plate assembly can be this one. Okay. So these components have different assemblies. When we develop the functions, we can see that what are the functions, what are the components. For instance, component number 6325, component number 6325 and their respective functions. Okay, these can be made as a group. We will see the groups when we will go to the creativity phase. So, this is group or grouping of the functions. This can be done. Now, information phase, that was just the bill of materials. Now, also we have the cost of the materials, the base plate, the material, the cost per piece and total cost. Total cost is this much is total cost, and because the total cost would be the cost per piece into the number of pieces. Now, this is the details of the bill of the materials. This is bill of materials plus the cost of the parts. So, this is number one, first component is base plate, the material is mild steel, first column is the part name, then we have the material, material is mild steel, because when we are talking about value engineering, we might like to change the material and we might have to see whether the other material works here or not, and also sometimes biodegradable material if possible in this pump we might inculcate, or we can have some manufacturing, use some material that is consuming less energy in manufacturing. Material cost is there and cost per piece. Okay, this out of this 32 and 25, 25 is material cost, 32 is the total cost. So, what does this mean? This means 32 minus 25, this is equal to rupees 7. This rupees 7 is my processing cost. I will again try to enlarge this thing. So, this first component is base plate. Okay. This base plate is made up of mild steel. The material cost is rupees 25. The cost of the component is rupees 32. Material cost means we will just weight the material. Like for instance, let me say mild steel is 40 per kg. I think during the time of the study it was around rupees 35 or 33 rupees per kg. That means this weight should be around 800 grams. 800 grams into rupees 25. That is the cost of the material, this cost of the material, and this is the cost at which the component is purchased. So, the difference is the processing and all those. So, processing cost is rupees 7 then. So, similarly, the cost of different components, for instance, this piston rod spring component number 7, this piston rod spring is made up of spring steel, okay, and this piston rod steel we didn't find the cost of the material, the only cost for the, because this was something that was bought from the market, that wasn't manufactured in the company. So, make and buy decisions also are the part of the material management or the purchase management. So, this was bought, not made. So, just the cost is there. So, similarly, we have the cost of all the materials. So, this is the major input that we have in information phase. Okay. This is a major input in value engineering study. Now comes the function phase. Function analysis is something that distinguishes and differentiates the value engineering technique from all other cost reduction or improvement techniques. So, in function phase, the functions of the components under study are defined. As I said, the function of a product is something that makes it work or that makes it to sell. So, functions may be classified as primary and secondary function, this all is mentioned, I am just recalling those things. So, the key factor or the key to value engineering is identification of what exactly the user or customer wants from a product. Customer is paying for the function, not the product. I am again repeating. There are certain rules for defining the functions. The rule 1 is the function should be accomplished in 2 words, as I said. All functions will be divided into 2 levels of importance, primary and secondary, as I said. So, the primary expresses the primary function is which is only one for a part or a product. So, what does air pump do? Why do we need air pump? We need to fill air in our car or maybe wherever. We need to inflate the objects. That object can be tire, that object can be my yoga ball or my football or anything. Okay, that is the primary function. Secondary functions might be I need to apply pressure on the foot pedal, I need to use my leg force, etc., all those things. So, what other secondary functions that we will identify? So, let us try to see the functions of the components. So, function for the base plate are identified as provide support, provide location, withstand impact, provide clearance. First thing I would like to mention here is that what is the function of my product? Function of my product is to generate pressure. So, the primary function for foot operated air pump was identified as generate pressure. We are trying to inflate the objects. How do we inflate? We are generating the pressure. Generating pressure, like when we just press the lever, it has to generate air pressure. It is actually generate air pressure, but because 2 words are to be there, we picked generate pressure. Okay. So, this air is taken away. So, this is the primary function. So, when we see this function definition sheet, base plate has a primary function, only one primary function would be there for each component. Each component has one specific purpose for which it is made. Okay. All other functions are just supporting or those are something that is making to work, make the primary function work. Okay. So, that primary function can be the primary function for the whole assembly, for the whole product we are talking, or that can even not be the part of the assembly, but that is there for the component only. So, base plate has provide support as a primary function, provide location, withstand impact, provide clearance as the secondary functions. This column represent the part wise function, the function definition, and this is the assembly wise last column. Okay. Part wise, this is the primary function, provide support, all other 3 are the secondary functions. Similarly, in foot lever we have transmit motion as the primary function, transmit motion. This is the primary function, all other are secondary function, and none of these functions are the primary function of the assembly. Now comes the cylinder. One of the functions in cylinder is generate pressure, which is the primary function for the part and also for the assembly. So, whenever there is a component or a part in which the primary function is the one that is the primary function for the product, that would remain the basic function of the component itself. So, we will see that wherever we have generate pressure, that would be the primary function for both the part and assembly. Okay. So, similarly, let us see where do you have generate pressure other than this. We have generate pressure here in the piston rod. Okay, this is something exceptional. In piston rod, the major function is to withstand impact of the components. So, generate pressure is a secondary function here. So, this sometimes exceptions also come. This is one of those. So, similarly, we have functions for each components, and we have also seen that the functions are not redundant. No, none of the functions is repeating. For instance, permit retention and facilitate fitment are separate. How are they separate? We will see when we will see numerical comparison. So, evaluation of the functions. I have only shown 10 components here. If you see this, we had 24 components. Okay, just for the 10 components I'm giving you this one, and we will provide you all other in the notes. So, evaluation functions, for evaluation functions relationship, there is need to determine the relative importance of various functions. The numerical evaluation is one of the methods that we did. So, this evaluation is determined through a paired comparison technique, which in turn leads to the ranking of the functions. So, numerical evaluation of functional relationship, this is if like Miles, the major figure in value engineering, is said, if there is no comparison, then there is no evaluation. Evaluation is always to be relative. So, the function has to go paired. So, that is why numerical comparison technique was used in value engineering. So, all the functions of the parts under study are considered from the functional definition worksheet. Functional definition worksheet, what is this? We will just see. These listed functions are then allotted with a key letter from A to T. We have functions which are allotted the letter from A to T. T means T is the 20th letter in English. T means there are 20 functions. So, to decide the importance of a function, following weight factors are considered and allotted to the function depending on the difference of importance between them. As we discussed in numerical comparison, we only used the 3-level scale: minor difference in importance, medium difference in importance, or major difference in importance. Okay. So, as function A is important from function B by using major difference, therefore, in the cell it is written as A3. A is important than B by a major difference, it is written as A3. This is what I have defined or explained in the previous lecture, numerical evaluation. In a similar way, all the functions are compared with each other. Hence, the table is completed and the total weight factor of each function is calculated. Then adjusted weight is calculated by adding 1. Why do we do this? Because in the total weight factor, no function could have 0 weight, as in case of function S. Let us see the numerical evaluation, or let us see the numerical comparison sheet. Okay, this is numerical comparison sheet. When A is compared with B here, B is important than A, that is provide location is important than provide support by a minor difference, that is B1. Similarly, function C is important than A with a medium difference, that is withstand load is important than provide support with a medium difference. Now, you see, this is from the customer's viewpoint. When we develop a numerical evaluation sheet, this is from the viewpoint, the way or the function for which the customer is willing to pay. You know, the basic thing is the customer requires something to generate pressure. So, generate pressure would always be the highest order function. The primary function has to be the rank 1 function. If that does not come, that means there is some error or some ambiguity in the development of the numerical comparison sheet. So, if we see this generate pressure, that is function L. Okay, function L is here. L is generate pressure. L is always the priority in this whole row and in this whole column. L is the priority. And how do we get this value 45? This is 3 plus 3 plus 2 plus 3 plus 2 plus 2 plus 2 plus 3 plus 2, so on, plus 2 plus 1 in the row here, 2 plus 1 plus 2 plus 3 plus 2 plus 3 plus 3, this is equal to 45. Okay. Similarly, we have the weight for all the functions, the total weight, the weight of importance actually. So, evaluation weight factor, this is difference in importance. So, this is the weight for importance, and one of the functions S is provide identification. Customer is not paying for provide identification. We have the stamp of the company on the body of the pump or body of the product. Customer is not paying for that. Customer is paying for the purpose. Number one is for generating pressure, they need to have a product that is something that is reliable, that is a proper fitment, that is something that can be carried, the size and all those things. So, it is not paying for providing identification. That is why provide identification, that is the company stamp or company's mark, is a 0 value function here. Function S is 0. Okay. As mentioned in the previous slide, we add 1 to all these functions to get these weights, because you know this value is 0 and this has to be a factor. Each function value, each of these values, this percentage adjusted weight, this has to be a factor, multiplicative factor, that has to be multiplied. Okay, that is why we cannot have 0. So we add 1 here to get these values. Now these are adjusted weight and the total value is, now these values are normalized. Normalized means these values are taken from the 100, we have just put the percentage. So these are normalized with respect to the value 100, and that means 13 out of 367, this 13 out of the total 367 is equal to 3.542 out of 100. So in this case we can see the highest value has come from the function L, that is 12.534, and the lowest value would come for the function S, that is 272. So this is the ranking. Now we'll put these values, the adjusted weight, in an ascending order and give them a rank. To confirm that numerical evaluation is correct, following checks of consistency are carried out as given by Mudge has found them satisfactory. The data obtained from the numerical evaluation should match the customer's requirement. Okay, weight factor of at least important function must be 0, that is function S in this case. No two functions should have equal weights. As I said in the previous lecture, if two functions are having equal weights, that means the functions are performing kind of a same purpose, or they are might be made for same purpose, or the functions sometimes the purpose might be different but the weights are equal. Then we have to adjust our numerical comparison sheet a little that to have the difference in the weights. Okay, no loop formation should be there. Loop formation is that, for instance, if suppose it is 2 2 2 2 something like this, loop formation is there. For instance, if I pick this loop, any loop, okay, at this node I have N2, this node I have F3 J2 N2. Okay, loop formation that they cannot be like 2 2 2 or the same values here. Now we develop the scree plot for the functions. Now what does this help us to do? This can help us to differentiate between the primary functions and the secondary functions. Now you can see the first drop is here. Okay, that means this is the primary function. The second drop comes here. That means, just ignore this thing. This is PF is primary function, this is secondary function 1, and these are secondary function 2. So functions N, R, G, C, E, F are the secondary functions, and these are secondary functions too, J, M, P, A, B, H. We can even divide it into further categories, but let us have only 3 sections here. Primary function, which is a basic function, secondary functions 1, and the tertiary function, the secondary functions 2. So this is scree plot that can help us to just have a visual feel of what is the difference and what is the slope in the difference of the importance of the functions. This is percentage weight factor, percentage actually importance weight factor I would put here. Okay, percentage importance weight factor. We can see here the high point is L, major first drop is from L to N, this L to N is major drop, second drop is from F to J. After leveling effect, first leveling effect is this actually, first leveling effect is N, R, G, C, E, F, N, R, G, C, E, F. The second major drop is Fj. The second and third leveling effect can be this JMP and after from A. JMP is second leveling effect, after this is third leveling effect. Okay, this is known as scree plot. and this drop is also known as elbow or knee. So again, this is the primary function. Okay, this is actually first major drop. Major drop means the isolation of the primary and the secondary functions. Leveling effect is, this includes the secondary functions, those are in the project to meet the specifications and requirement. To meet the specifications. Okay, this is the second major drop. So this is separation of the two types of secondary functions. Separate two types of secondary functions. Second and third leveling effect are the functions, these are secondary functions, those are in the project because of the present approach due to current design. This is a general takeaway from this scree plot. Okay, from this scree plot. Now, function cost matrix and VIP. VIP is value improvement potential. I did not explain this in the value engineering methodology when I was just giving the overview, but this is a detailed study. That is why I am trying to explain that how do we develop the costs for the functions and we develop the value improvement potential. So, after relative importance for each function is identified, now it is essential to determine as how much is it costing to provide a particular function. The cost of components is distributed to the functions performed by them, and hence the total cost of accomplishing each function, and then the percentage of cost for each function in assembly is calculated. I will show you in the table in the next slide. Next step is to divide the percentage cost of functions by percentage importance, that is the weight factor that we have generated in the numerical comparison from numerical comparison. Okay. This gives the value improvement potential index, VIP index for each function. Functions having VIP more than 1 are poor value functions. VIP means improvement potential. If improvement potential is more than 1, because this is the ratio of the cost and the importance, cost to importance. Value is actually, I can say, importance or utility per unit cost, but VIP is proportional to 1 by V. Value is something separate. The functions which are having this value greater than 1 are poor value functions. Greater than 1 implies poor value. This greater than 1 implies good value. So, we are talking about VIP index here, not value. Okay, I am putting a cross here. We are talking about this, not this. This is function cost matrix and value improvement potential. This was developed for the whole product. All the functions are listed here, functions from A to T in this line, and these are the components. Base plate, 24 components are there, quantity is also here. Okay, these are the components here. I will put it here. These are actually functions, these are components. The cost of the components, we know the total cost of the component for the base plate is rupees 32. Provide support. Now this base plate is having total cost of rupees 32 and it is performing these functions: provide support, provide location, withstand impact, okay, A, B, C. Function D is provide clearance, and that's all. Okay. Similarly, the second component, foot lever, is trying to perform these functions. Foot lever is costing rupees 30. It is providing support, it is providing location, it is withstanding impact, it is facilitating movement, it helps to join parts, it helps to transmit motion and so on. So any function that is not in the part, that element is just left blank, like this element is left blank. So out of rupees 32, what is the cost of providing support? Rupees 12. Rupees 10 is the cost of providing location. For instance, providing location, to provide location, the material has to be part of that. We need to drill holes to provide the location. What is the cost of drilling holes, and what the strength of the material? For instance, it is taken, the material for the first component base plate was mild steel. So mild steel, why mild steel is selected? Because this size of mild steel was required. The material cost is divided into these components. This is done by the production people who are involved in the purchasing, who are expert in material strength, the people from mechanical background. They can help to divide the cost into functions. So in this way, we develop the cost for each function. For provide support, we have got this cost. It is in base plate, it is in foot lever. Total cost is, this is 14, 14 is actually 12 plus 2, 14. So the total cost for the functions is here. This is the total cost for provide location. 36 is the total cost for, 14 is the total cost for provide support, 36 is the total cost for provide location, okay. And withstand impact, 41 is the cost for the function withstand impact. Function C is costing rupees 41. In this way, we get the total cost for each function. We have the percentage cost, we are normalizing this again. So this is total cost for each function is there. The total cost for the components, all these components, the total cost for component is rupees 351, which is the cost of my product, and total cost of function as also to be this one, rupees 351. So this is the total cost for each function separately in the columns. This 7 is the total cost for one function, 6 is for the other function, and we have again normalized this. The value 3.977, this value comes from this ratio 14 by 351. 14 by 351 is 3.977, 36 by 351 is 10.292. Again we are normalizing with respect to the total cost on the value 100. So we have got the percentage cost and we have got the percentage weight, percentage cost and percentage weight. Now the cost to weight ratio is VIP, value improvement index. This 3.977 divided by 3.542 is 1.123, this value. Similarly, in the function C, 11.719 divided by 8.447, this is 1.3. Okay, any of these values, value improvement index, improvement potential actually, this is potential or the functions where there is an improvement potential, where there is a scope of improvement, and this value is a quantified scope, the level of scope. If the value is, for instance, one of the functions here, provide location, there is a very high scope, the VIP is 3.150. We can see it in this way as well. From the percentage weight, was the importance weight, this was the importance weight. From the customer's viewpoint, customer is willing to pay rupees 3.150 0.27 for this function, but we are spending rupees 10.29. Okay, around 3 times of money is spent on accomplishing this function. Sometimes this is important when there is no other way, this has to be done, but this is one point where the potential of improvement is there. Okay, so this is VIP index or value improvement potential chart and function cost metric as well. This is the function cost, the cost of the functions. Okay, these are the cost of the functions, and this is the total cost of the functions. This is total cost of function. This is normalizing. This VIP is this VIP is equal to percentage cost by percentage weight. VIP greater than 1 implies work on these functions. Okay, so this is value analysis. People have different definitions for value engineering and value analysis. Some people say that when we are talking about engineering applications or manufacturing applications, it is value engineering. Value analysis is whenever we talk about services or something that is not in manufacturing or not in construction, that is value analysis. But some people also have come up with this definition that value analysis is that when we have analyzed the poor value functions, till that point it is value analysis. But when we move forward from that and try to also suggest the alternatives, that is engineering. So this is analysis part. Now we have identified the poor value functions. To make it more clear, we can even develop a indifference chart. Indifference chart for the foot operated air pump, following are the poor value functions: provide support, provide location, width and impact, provide clearance, joint parts, provide alignment, provide identification, measure pressure. These are all the functions which are having VIP value more than 1. So now the foundation had been laid down for application of various techniques to generate every possible solution to the problem. So this is indifference line in which we have plotted percentage weight of functions against the percentage cost of the functions, and this is the indifference line. Any function below this line, because this is the ratio of weight to cost now, that is a poor value function. So these are poor value functions. Indifference is the value is exactly 1, less than or greater than 1 would be at the lower side and more than 1 would be at the upper side. So this is one of the way to see the functions. Now comes the creativity phase. In creativity phase, we need to work on these functions which are identified as the poor value functions for support. Now we can make groups of these functions and we need to see which components carry these functions. Those components, if they can be grouped together, we have picked this worksheet. First group, the parts are base plate, piston rod pivot, lever springs, support pin, foot lever pivot and lever spring. Functions those are performed are provide support, provide location, width and impact, provide clearance and joint parts. So ideas other than the current design now can be speculated. So these are the ideas which were just feasible. For instance, in creativity worksheet 1, these are done in conjunction or with suggestions of the manufacturer, from the various people who were in the manufacturing concerns and the friends. So these are the specific ideas for this specific product. Use this size square for base plate, round bar for piston rod and quarter pins for this. So as and then search for new suppliers for lever spring, use round bar for piston, use MS angle of this size. So these are the specific design requirements, because we are talking about the mechanical component here and this group of components. So these are the ideas. For instance, there are 7 ideas which have come. However, I think in creativity worksheet 1 there were around 12 ideas. When we talk about creativity, we just forgot about the facts, as I said, and we just come up with the ideas without even thinking that whether it is implementable or not. But sometimes in the preliminary feasibility test, these some ideas are just eliminated, just taken off. So they are just kept in record. They can be taken in future if the availability or it is possible to implement those in future. So these 7 ideas were taken, which would be taken to the evaluation phase. Similarly, we have creativity or creative worksheet number 2, in which we have these 2 ideas, actually not 2, actually there was again 7 ideas. I am missing a slide here. I will provide you the detailed worksheet in the notes. So this has these parts: foot pedal, foot lever, gauge adapter, cylinder pivot. So the functions were withstand impact, provide location, provide support, provide alignment and joint part. These are the ideas for them. Now evaluation phase comes into the picture. In evaluation phase, the objective is to analyze the results of the creative phase. So this is by thorough review of various alternatives to select the best idea for the cost reduction. The skillful application is triggered at for the prevention of unnecessary cost, development of value alternatives. Though this is done while keeping in mind or ensuring that the product is not cheapened or degraded. We cannot just reduce the performance or quality. That means to make sure that there is no reduction in durability or ease of operation or other aspects. So below the requirement of consumer or the customer we cannot go. So in order to guard these possibilities, this phase employs following techniques: establish cost on all ideas, evaluate by comparison. This is 1 and 2. So each idea is there. Now what is the cost of this idea? What is the cost of idea number 2? We need to establish cost for this idea. This is done in evaluation phase. So establishing cost for ideas, the cost for all feasible ideas is established. For this purpose, ideas are written in the following manner. Now the cost for acceptable idea is estimated and allocated, and reasons for unacceptable ideas given. So we develop this kind of function evaluation worksheet. This is again parallel to or corresponding to creative worksheet 1. These are the same functions and parts which were there in the creative worksheet 1. Now in this case, the present design cost is put. In the present design cost for these components, what is the cost and what is the cost of our idea. Okay. So present design cost is rupees 3067 and our design is rupees 77, rupees 107, rupees 67 and so on. Okay. This is the, if we try to implement our design, what is the cost of the components or the suggestions that we have given: base plate, quarter pin, piston rod, lever spring and so on. Okay. These are the other ideas. We have developed costs for each ideas. We can see that the present cost is rupees 67 and the purpose of this study is actually reducing cost using value engineering. So 67 is the present cost. All these costs 77, 107, only 67 idea number 3 is equivalent to the present cost and idea number 7 is lesser than the present cost. But these are all acceptable. Acceptable means these are feasible. Similarly, we have all these acceptable ideas. Some idea might be not acceptable, that we have taken off from the worksheet. In evaluation phase, after allocating the cost to the ideas are evaluated by comparison using an appropriate criteria of evaluation for selecting the final acceptable ideas. The criteria for selecting the idea is the cost savings, durability, ease of implementation, ease of operation. People can have many like availability, then we can have resistance of employees. Some ideas that we can have any number of ideas here. Okay, but these are the major 4 criteria, not ideas. These are major 4 criteria. Those were taken. Also, we can have green criteria that I will just forthcoming slides here. So based upon these, first of all, we need to rank these cost savings, durability, ease of implementation, ease of operation. These are again ranked using numerical evaluation phase. So A, B, C, D. The highest rank is for A, cost saving. The second rank is for B. Which one is durability? Okay. This is the third rank. This is the fourth rank. Okay. This is rank 1, 2, 3, 4. This is rank the ideas. And in decision matrix is finally made. Decision matrix is the matrix that finally tells us the score of the final idea that it will tackle to the implementation stage, and then we will see. So the decision matrix is made to finally select the idea. The ideas are ranked by finding value scores of ideas using weights from numerical evaluation of criteria, and a 5-point scale is mentioned as under. The idea is excellent, the idea is very good, good, fair, poor. How are these used? I will show you the decision metrics for the cost savings. These points are given as no saving is 0%, we are just quantified in this way, between 0 to 20%. 0, no saving is 0, and these are the 5% classes, between like less than 5, 5 to 10, 10 to 15, 15 to 20, 20 or more, full 5 points are given. This technique is used to assign points to each idea for each criterion. So, this is the way we try to find the final score. So, this is again decision matrix, which is corresponding to function evaluation matrix, which is in turn corresponding to the creative worksheet number 1. This is decision matrix for the 1. So, these are the criteria A, B, C, D: cost savings, durability, ease of implementation, ease of operation. So, these are the ranks which are given. We need not need to have ranks, we are just having these values 7. So, this is value 3. The points durability, the cost savings are 0 for all these things, all these ideas. If you remember, only this was having cost 45, okay. This was having cost 45 and the savings were more than 20%, more than 20% saving. So, that is why it is given the value 5 here, and this 5 into 7, this 35, this is 5 into 7 is equal to 35. This 7 into this 5 into 7 is 35. Similarly, the cost were just quantified, and the other criteria, durability, ease of operation, ease of implementation, were seen. For this idea, what is the durability? For this idea, the durability is given the point 4 out of 5. For this idea, durability is given point 3 out of 5. This is very durable idea, and it is given point 0.5. Now, how this is actually again a subjective rating given by experts. Now, this 5 into 4, B is equal to 4, this 20 is again 4 into 5 is equal to 20. Okay. Now, all these values are summed up, 0 plus 20 plus 1 plus 3 is equal to 24. So, this is the score, highest score is gotten this idea, use sheet metal fabrication. So, this is the idea that is selected to be taken to the further development and implementation phase. Similarly, we have decision matrix 2, in which this idea is selected, use sheet metal fabrication process for foot, lever and foot pedal and threaded cylinder pivot. And we can have the green criteria in the evaluation. In this study, we did not actually worked on the green criteria, but yes, we can have the green criteria. We can have these 3 areas here: before use, during use, after use. Again, for each one we can think of the material, we can think of energy and pollution. We can think of these as positive, 0 and negative for each one. If we have this green criteria, then we have 2 different ratings. This one is for quality or performance, quality or performance, and this one is for the environment. Okay. So, this green criteria helps us to have a green product. That is why we have mentioned here decision matrix 2 with green criteria, and this makes it to be called as value engineering green plan. Okay. We have not done this for this complex product, but I will just do the green criteria and the quality criteria for a simple product, for a chair or for a pen. But let us see what is the final decision that can be taken from the current study that we are taking. In implementation phase, the proposals, those are finalized after evaluation and brought forward to investigation phase. Combining changes means the same parts. For instance, there are certain creative worksheets. There were actually 11 creative worksheets which were developed, of which 7 were used. out of these 7 creative worksheets, for instance, if there is creative worksheet number 2 and worksheet number 3, there is some idea that is selected, and these parts are again to be combined actually. These are going to be combined because of those are talking about the same parts. So those changes are to be identified. So those were in different groups of parts. So they have been made through creativity phase, but those need to combine here. So it is observed that most of the final proposals involved in different parts except the foot pedal, which is there in final proposal in group 2 and group 6, these are to be combined. So specifically group 2 and the decision matrix 2 and decision matrix 6, there was different parts were there, but the foot pedal was the common part here. So these were combined here. So next we present the cost. Now new bill of materials is developed and showed, that shows the modifications, additions, eliminations, modifications, additions and eliminations of some parts after value analysis. This is actually value engineering. Presenting specifications, the drawings are prepared showing the details of the modified and new added parts for clarification of the proposals which will be used during implementation. These are presented before the management or the people who are going to invest for the new setup of the new components. This is the proposed bill of materials and cost of parts. The color blue is the modified parts. Okay, piston rod pivot is modified and new cost is here. Plastic bucket is modified, foot pedal is modified. These are the modified parts. Okay, bucket washer is eliminated because the purpose for which this bucket washer was being used is now fulfilled by some other assembly, some other arrangement. So this is eliminated. Again, these hexagonal bolts etc. are eliminated. Company sticker is eliminated, that is not required here, they said. So these are new added parts. Cylinder cap bush, a cylinder cotton pin. So the total cost is rupees 252. If you remember, the previous cost was rupees 351 and the new cost is rupees 252. Then we can present the savings. Rupees 351 is the total cost of the current design. This is the proposed design. So saving is rupees 100 per pump. This is quite high, 28.2% savings is there. So to present the facts, the company on an average has sale of 200 pumps per month. So per month savings could be this one, using value engineering approach. When we talk about the implementation, there's certain difference between the actual and the planned things. As I said, in implementation phase, there those things are to be taken into account because we are set up and there is a change in the setup on the plant layout. Sometimes those things have to be made. So there is resistance to change sometimes and people do not implement the things. So this is value engineering methodology for a foot operated air pump. Now I have a task for you people. Now you have seen the methodology. I would just request you, the product that you have selected, you have already selected a product, next you have identified the functions, now try to find the cost for the functions and rank also you have developed for the functions. And try to find VIP, value improvement potential, VIP, and try to find the poor value functions. This is the task for today. So I believe most of the value engineering green plan stuff is covered now, and by this, while watching this lecture, you have seen how the study on value engineering is carried out and how the green criteria can be instituted while we talk about the criteria in evaluation phase. I'll definitely come with a study using the green criteria while taking a simple product and just picking 4, 5, 6, maximum 10 functions. So, we'll meet in the next lecture and we'll discuss more on value engineering, and further we'll discuss the other modules of this course, and we'll also have the software presentations when we'll discuss the life cycle assessment or green factory design. We'll have the software presentations in that, and life cycle assessment, definitely we have the online available tools we'll discuss, and the open access softwares, and there are some softwares which are available in our institute IIT Kanpur, which are not open access, but those are very good tools to work on the green design. So, let us meet in the next lecture and we will discuss more on advanced green manufacturing systems. Thank you.